This is Unlock the FRQs, and we're on the final boss, the qualitative quantitative translation question. This is the one where they say you need to not use equations. And maybe you're like, wait, what? Not use equations? But this is physics. I only know how to use math. What do I do? Well, let's look at a question. This question is about two blocks. Initially, there's one block sliding and it collides into the second block and they go off together. The mass of block 2 is much smaller than the mass of block 1. And they ask us estimate the speed of the two block system after they go together and justify your reasoning in qualitative language, not using the math formulas. So this question always follows a three-part journey. 1, 2, 3. The first part is where you have to use English words. It'll say, here's the situation, what's going to happen, and justify using qualitative reasoning beyond using equations. So for these questions, if you wrote down an equation, you'd get the answer wrong. You need to use English words and logic and qualitative reasoning, kind of like this is bigger, so that's bigger, or this is a quantity, so that's a quantity kind of language. In part B, we're going to do a derivation, which is the math part. So now we're going to use our math skills and derive some formula. And in part C, we're going to connect the two. We're going to say my A reasoning and my B formula fit together somehow. Let's look at the question. So the correct answer is that the final velocity is approximately the same as the initial velocity. The velocity doesn't change. It might change a little tiny bit, but it's approximately the same, and we're being asked to estimate here. So maybe you look at this question and you say, I have no idea how to do this without math. Math makes me feel safe. Let's see how to do this using English words and reasoning. I'm going to cite the conservation of momentum and begin by thinking about the momentum of block 2. If we think about block 2, it's got a very small mass. Because it's got a very small mass, its momentum compared to block 1 is very small. So it does have a velocity after the collision, it does have momentum, but its momentum is very small. That means the change in momentum that block 1 gets is very small. There will be maybe some small change in momentum, but it's negligible. So approximately the momentum of the block 1 initially is going to be the same momentum it has afterwards. So block 1 doesn't really go through a change in momentum. Its change in momentum is almost zero. So we could say that the mass of block 1 is the same, so its velocity is almost the same. Let me read the answer that they give in the question so you can see the kind of thing that they're looking for. I want you to think carefully about how you would try to answer this question without equations and see how they answer it. If the mass of block 2 is really small, the final momentum of block 2 will also be really small. This means that the change in momentum in block 2 is really small. The change in momentum of each block is equal and opposite, so if the change in momentum in block 2 is small, so is the change in momentum of block 1. So block 1 is still traveling at approximately the same speed. So we see at the end, there's the correct claim. We see they cite the fundamental law of momentum being the same. And thirdly, they use the logic of the block being really small, and that's the 3 marks. Now this part is going to have 3 marks, and so we need to do 3 things to get all 3 marks in this part. Firstly, we need to say the correct answer. Secondly, we need to cite a fundamental physics principle. And thirdly, we need to connect the two with some kind of logic. On my website, I have a PDF about the FRQs. It goes through the 4 kinds, how to do them all, and there's some practice questions as well. It's totally free. Click the link below to go get it. So in part 1, we need to use this English words justify your reasoning qualitative thing. In part 2, they now say derive an expression. So now we're going to use math and do formulas. So here they say we have the general situation where there's 2 blocks that collide. One has a velocity, the second has no velocity, and after they collide, what's the velocity of the 2 block system afterwards? So here's my initial situation. That block's got a velocity. And here's my final situation where they're moving together. Now this question is actually also worth 3 marks. Usually derivations are worth 3 marks. And how do I get the first mark? I write down a fundamental physics principle. So whenever there's a derived question, we always write down a fundamental physics principle. Here, I'm going to write down the conservation of momentum in the equation form. There you go. That's already 1 out of 3 marks. Now, I need to do a little bit of derivation, so I'm just going to put in the right variables. So we have mass 1 times v naught. That's the initial momentum of this block. This is the initial momentum of the second block, and the velocity is 0. And then this is the momentum of the 2-block system afterwards, where the masses are combined. So we just set that to be 0. And now we divide by this mass term here. And now we're done. So here we get an answer for Vf, m1 v naught divided by m1 plus m2. Now again, this is the general formula for whenever there's these two things, not necessarily the case in part 1. And this is for 3 marks, so get this. 1 mark for writing down the fundamental principle, 1 mark for the correct answer, and a 3rd mark for doing some algebra in the middle. Okay, that was the derived part. So the first part, we use some reasoning to estimate. The second part, we do an equation, and we get this answer. And in the third part, they're going to get us to connect the two. It says, does the equation you derived in part B agree with your qualitative reasoning from part A? Justify why or why not. So again, we need to use some words English reasoning rather than equations. What we're going to do is think about this thing that we got in part B and say, does it fit or does it not fit? So I'm just going to leave that up there. So we're thinking about the case where M2 is very small compared to M1, and does this fit with what we said? So in part A we said Vf would be approximately equal to V naught. So you want to begin by saying, yes, my equation from part B fits with my reasoning from part A. Basically, you want to say that if M2 is so small compared to M1, it looks a little bit like the denominator of M1 plus M2 is equal to the numerator of M1, and those terms are going to cancel. So approximately Vf is going to be equal to V naught. Again, let me read you their answer so you can see how they would do it. Again, you should think about how would I answer this question with English words, writing down sentences, and let's see what they said. In part A, I claimed if the mass of block 2 was much less than the mass of block 1, the final speed would be approximately equal to the original speed of block 1. In the equation I derived, part B, since the final speed of the block is inversely related to the mass of block 2, if the mass of block 2 is very small, it will effectively mean that the masses in the numerator and the denominator cancel, leaving the final mass equal to the initial mass, which is what I claimed in part A. Did you see that? The key thing is we need to talk about the relationship between this Vf and this M2 and how that connects to what we said in part A. And if this one is 0 or close to 0 relative to M1, then Vf is going to be the same or similar to V naught. I hope you can see the 3-part journey that this question follows. We use qualitative reasoning, we then do an equation, and we connect the two. And this whole question altogether is going to be for 8 marks.